All right, the first one you just have to memorize. Okay, the radians, that is. But nobody has problems remembering the radians on the first one, right? 0, pi over 6, pi over 4, over 3, pi over 2. Y'all with me? All right. Do you agree that all the denominators are the same as you move across, right? Look at your unit circle and the denominators that correspond to those degrees. So if you drew a line, they're the same denominator, right? So this is going to be 3, 4, 6, right? This one's over 2. This one, you have to memorize these two. And this one would be 3, 4, 6. The same numbers always touch each other, okay? Y'all with me? All right, so memorize the first one. Memorize all of them for the A. For the S, you subtract 1 from the denominator of each of the corresponding angles. So for the 3 one here, you subtract 1. So that would be 2 pi, 3 pi, 5 pi. So you have to memorize the first quadrant. Okay? And when you're labeling them, the denominators, the same denominators touch each other. Okay? So 6 is 6, 3 and 3, right? Yeah, I got that. Okay. You subtract 1 from the denominator of each of these, the one that corresponds. So the 3, so subtract, subtract, subtract. Well, here you add 1, that's the A. So this would be 7 pi, 5 pi, 4 pi. I'm adding 1 to each of those denominators. The only one that's a little bit trickier is the P one, and that's for prime. And we start at 5, and we do prime numbers from 5. 5, 7, 11. Can only be divided by 1 in itself. So that's easier than converting, right? ASAP. All. You have to remember all of them. Yeah. Easier? Is that better? Is that a little trick that can help you maybe? ASAP? Yeah. You use them enough that you do, but. All right, y'all ready to go over some of these circuits? Anybody ever hear from Wyatt? Oh, I need to. Yeah. Is there one prior to? What do you need? Yeah, go ahead. All right, 6 is the first one I hear. I haven't finished mine. All right, the one that leads up to number 6 or number 6 itself, like the one that says cosine squared x sine x. That one. All right, cosine squared x. Some of these you're going to look at them and go, oh my gosh. Number 6, so very last page, bottom right. You should have this for number 6. If you don't, your circuit has gone awry elsewhere. Yeah. Flip it over to the back. Very last page. That should. You should have written 6 in that. You should. What? Oh, that's right. That's right. Did you get a Trig identity sheet? Okay. Oh, that's right. I get you. Okay, so the way a circuit works is we're working our way. We're starting in the very first square. We work it. We find the answer to that, and then we look for that answer in the circuit. Well, you can start at 6. Put a 6 on this one, and then you can go back and do the beginning ones. Put a 6 on this one. There you are. That's where we are. Yeah, but you can go back. No, yeah. No, not to do that one. Yeah. Well, it's getting frustrated with you. Don't need them, Dylan. Just Work forward from here. Okay, so I'm going to simplify as best I can, right? Remember, cosine squared and sine squared simply means 2 times, okay? And you may not use identities for all of these, and you may. But here, what I would start by doing is saying, okay, so I know that one of these cosines and this cosine can cancel. This sine, and this may or may not help me, but I'll see. Cosine x over sine x, which looks very familiar to me. In fact, if you look on your handy dandy trig identity sheet, that is actually cotangent. So now, search, search, search. Where is cotangent? Where is cotangent? Is there a cotangent? There is, in fact, on the previous page in the middle on the left is cotangent. And that would be number 7.
Right, so why don't we square?
This is the same thing as cosine x, sine x. And I should have mentioned that yesterday. I'm sorry. I forget. That's okay. We put, when we have a trig function, we just generally put it there on the, so that it doesn't get confused with the x, and so we don't think the x is being squared. We know the whole thing is being squared. All right, so then we move to number 7, and number 7 was, and I'm not going to do all of these with you, but I will get you through the, I think a lot of us are stumped on 8. Okay, so 7 is sine 2x over 2 cosine. And so if you look at this, you're probably thinking, what am I supposed to do with that, right? But on your sheet, on the very bottom, there are 3, cosine has 3 double angle identities. Sine only has 1, but cosine has 3 there. And you can derive all of these different ways, but we're not going to get into that. Just take my word, those are the identities. So you need to decide which might be the most helpful to you.
The bottom one on the left.
The bottom on the left?
On the trig identity sheet, you have it.
Oh, sine's 2x. Yes, I do. I thought I was... All right, so 2 sine x, cosine x. Well, I read that, I said sine 2x, but I read it as cosine 2x, and I was looking at the 3 cosine double x. Never mind. Yeah.
No!
Cosines go away, the 2's go away, and I'm simply left with sine x.
8 being like 8, honestly, it's traumatizing.
While you're still here, be very careful. No offense, Leah. No, I'm just kidding. She's not listening to me. Yeah, if you see this, nothing is canceling. Okay. Remember, we're only canceling because we're multiplying. If we start adding and we start canceling, we start killing kittens, right? No, none of this would cancel here. You can't cancel any of that.
Why not?
Because you're adding and subtracting. The canceling part only works here because I am multiplying. Don't kill kittens. See the poster at the back? Don't kill kittens. Every time I say you're killing kittens, it's because you're canceling when you shouldn't be, when you're adding and subtracting stuff.
What is that answer? You got circle?
Sine x.
I know that. What do you got circle?
Oh, no, that's just a random. Yes. Yeah, 7. So now I find sine x. Where's sine x? Okay, here we go. Now, the question was asked yesterday because sometimes you'll get an answer and you don't see your answer anywhere on there. You may have to manipulate your answer to try to see which matches, okay? And that can get a little bit difficult. Now, let me say this, and I had everybody write this on their sheet yesterday that was with me, but if you weren't with me after school yesterday, well, not after school. No offense if you have a 4th block and you actually have class and you can't. We were just having a little sesh. Don't drop a push. Oh, no, I'm sorry. What class do you have? Oh, you're off campus,
I have
Jeff.
law enforcement. We spend hours putting handcuffs on people every day.
Sounds like fun. Though.
It's actually really fun, except for my wrist.
On your Trig Identity sheet, where it says sine squared x equals 1 minus cosine squared x, also write there on your sheet that negative sine squared x is equal to, if I change the sign on the left, I can change every sign on the right. I've just multiplied both sides by -1, right? Cosine squared x minus 1. It's the same identity, right? Do you see that? If I multiply this side by -1 and this side by -1, that's what I end up with. And that comes up a lot. Okay. I took the blue one and I multiplied both sides by -1.
By the left by -1?
And the right. Because it's an equation. If I do it to one side, I can do it to both. I can do
How
that.
does that help you get an answer?
Because look at the denominator. I'm going to show you.
So, yes, you changed that.
I'm just telling you that's an identity that you should, that's a kind of a corollary to that identity. It's the same thing, okay? So what I'm getting to is this denominator could actually be written as negative. And the reason this is helpful is I see this sine squared on top. Now, but I can't cancel it because I'd kill a kitten, right? But there's... What if I write it in separate fractions? Could I do that? Like, could I say sine squared x over negative sine squared x? Okay, so this you have to be very careful. I'm going to make this plus negative cosine 2x, just so you see, because I'm not subtracting all of this, right? So I'm going to say plus negative cosine 2x plus 1 over negative sine squared x. It was subtraction to start with, so I just made it plus a negative. I didn't want anyone to say, why didn't I put a minus here, because the cosine was, yeah.
Why would you put the other sign on the right? You already put it on the left fraction. Why put it on the Oh, so that.
Okay. Okay. The first fraction is easy peasy, yes? What is it? -1, right? Do you see a double angle identity that I could use to get cosine as a sine?
Oh, wait, but that's negative. No, it doesn't have to be though. You do it another. Are you talking about the cosine 2x?
I want a double angle identity that's going to convert cosine into a sine. The last one, I only want a sine in there because that's what the denominator is. Okay, and I want this as simple as I can get it. So I'm going to convert negative cosine 2x to, remember it's negative, 1 minus 2 sine squared x. But I still have that plus 1 on the end, right? That was, it always comes at the most convenient times. Okay. Is anybody confused on that?
Can you tell me the things that you said to write the people yesterday for the block? You said 2 things.
This. That was it.
Oh, it's on that.
Yeah. All right. I'm going to distribute this negative sign through. Okay. So I have -1 plus -1. And if you didn't take all these steps, but I want you to see this. Plus 1 over negative sine squared. Okay. What do you notice? It will, but not yet, because first, the ones on the ends. Right. It's okay, Leah. You really don't like cats, do you?
Wait, so you put the -1 over 1.
This cancels first. But you're right. It does. But not first. Right, Leah? All right, so I have -1 plus 2 sine squared.
Well, you just subtract, right? Oh, you can't subtract.
Yes. There we go. No, I distributed the negative. Oh, on ours, because I took the negative from the bottom, and it's still, I'll show you. Okay. Negative sine squared x. It's still negative because of that. Now, Leah, we're ready. Cancel the sine squared. Yeah. I have -1 plus -2. Would you have ever looked at that fraction and thought, by a stretch of your imagination, that it would equal -3?
No, because I'm.
It's crazy. No, you're not. Don't say that.
Hold on. Miss McGee.
You will memorize the trig identities, yes.
It'll take us a while.
It will take a little while. For a while, when you need them, I'll let you use your sheet until I gradually get you to the point where you don't need your sheet. You will. The more you use them, you'll remember them. They will. I also have them on your unit circle here. Some of the important ones are on there too. Pythagorean identities come up all the time, and double angle comes up all the time. I don't know how often sum and difference identities come up. They're more for finding exact values, but you use it in this circuit. But as far as calculus goes, I don't see those used as much. There's still game on the exam for sure. All right, so that was number 8, which leads us to number 9. So you think y'all can do that?
Okay, hold on. Let me just try this one.
That one was not bad. Yeah. I will give you a hint on that one. Convert your cofunctions. Okay, I won't. Okay.
Why? Why don't you trust the leader?
Wait, can we work it out?
You want to do it on that board or this here? Okay.
Right.
This up.
Give us a second.
Don't look. She's gonna do it, but don't look.
Will that turn into a pillar of salt?
Wait. Why is it not working? The touch is definitely again. Try it now. All right. Well, you might have to do it on here. This is fun. You can touch with your hand. You don't have to hold your hand. Okay.
I actually thought that was a Greek mythology. All right, well, it's in Genesis.
Good job.
How'd you get the 1 under sign?
You look up.
No, I thought y'all told me not to do. That's what y'all weren't listening up to.
Yeah.
Okay, so you convert and then you FOIL. So
Arrows
this.
to show your work.
So
So the second line is just you converting everything?
yeah.
She just changed all the code functions to reflect
So
the function.
I'm gonna go from here to here,
How did you
here
do?
to here, here to here. Huh?
How did you do 1 over sine? I know how you got 1 over sine x, but how do you get plus cosine x?
Oh, that's actually
Because
smart.
cotangent is cosine over sine, just how tangent is sine over sine. Okay. I'll wait until you're all caught up.
Go wait. Go wait.
This is fun. So technically, oh wait, you're back there. What are you talking about?
On the second line, you didn't put it.
Do I have to?
I mean, yeah, because if you don't.
Okay. This was. Can I move on? Can I move on?
No. Not yet. Well, I'm on the third line.
Okay, so the first cosine x over sine x and the last cosine x over sine x cancel because it's cosine x over sine x minus cosine x over sine x. Okay. Yeah. So now, what did I do?
They're the same denominator. You should combine them.
Oh yeah. Wait, okay, so you put it all over one big fraction, right? So -1 plus cosine squared x, over sine x.
Now what do you notice what we wrote?
I do have one more question.
Mm.
How did you get the cosine x over sine x? It was -1.
Huh? So now, is it? Do I have to put a -1 on the outside?
Negative sine squared. That's the one. Remember the one I told you to write under? So 1 minus cosine squared is sine squared. So if you change all the signs, it's negative sine squared.
Oh, so.
Negative sine squared.
Mm.
So that's the identity y'all just wrote on your paper.
Yeah.
And I messed the other.
I think I did a good job.
You did a great job. Thank you. Wow. Okay.
Was Adam Sandler?
Let me try to do the next one.
10. Where's 10 now? Where's negative sine x?
It's on the last. No, it's middle. The last page is on the.
All right, do 10, do 10, do 10. Because I really want us to get through 12 together.
Use an angle sum or difference identity to simplify cosine.
There's another one I want us to do together too. This is straight off of the identity sheet.
Yeah.
Nice one, Noah.
Look in my desk, Meg. Look in the far. It's okay. Look in the far left drawer, and there's some napkins in there. Keep going.
So,
Keep going.
this one?
No, yeah. No drawer, desk drawer, desk drawer.
Desk drawer, man.
There you go.
This one. So like,
Yes.
so it would be. What do I do with the?
Huh?
What do I
So
do with that?
cosine.
So I know.
Well, so you just it's cosine pi cosine x plus.
But what about the
sine.
negative?
You don't worry about that because this formula takes that into account. What's cosine pi? What's the cosine of pi? -1. What's the sine of pi? 0. So this is just negative cosine x, and we move on to number 11. Top right. So this is one I do want to get to that I want to talk about. Last page, top right. Oh no.
I really just messed. I did a W on that. But I guess
Yeah. All right, what is the sine of pi? So you go to the unit circle, go to pi, what's the sine? Okay, so I plug that in for sine pi. What's the cosine pi? And so you plug that value in also. Okay, so it leaves negative sine x. So it's -1 times sine x plus 0 times blah, but that doesn't matter because it's 0. So it just leaves you with negative cosine x. All right. This is the hard one. For your answer, in order for your answer to match the answer on the answer key, you have to use the right reference angles. Okay? So it tells us to use sum or difference identities. So I know I'm going to be adding two things together that's going to give me 5 pi over 12. Okay, are y'all with me? Well, my thought process as I worked through this was, what denominators can I use that are in the first quadrant that would have a common denominator of 12, that whenever I added them together, they're going to give me 5 pi over 12. This one was hard to think about in radians because of the fractions. And so yesterday, we tried 2 and 3 yesterday. We tried 3 and 4 yesterday. And what we found worked was 4, 6. So what if I add pi over 6 plus pi over 4? They have a common denominator of 12, yes? I need to multiply this one by 3 and this one by 2. Does that equal together? Okay, that to me was the toughest part of this problem for me. So what I'm going to do, right. Well, but I went backwards on finding a common denominator. I had the common denominator, but I need to find the two fractions that added to this. Yes. 5 pi over 12. This is what I started with. This was the problem. I started thinking, okay, if I'm in the unit circle, if I'm in that first quadrant, I've got denominators of 3, 4, 6, and 2, right? Of those, which ones, if I add any of those two together, are going to give me 5 pi over 12? Okay, so to find the answer, it said use sum or difference identities. Okay, so I'm going to do sine of pi over 4 plus pi over 6. So now I look at my sum and difference identity on my identity sheet. The sine of A plus B, so the very first one, right? Y'all with me? So sine pi over 4, sine pi over 6, plus cosine pi over 4, sine over 6. Very first one.
Oh, well, that's where I messed up.
Right? What is, now this is where, as long as I've got that first quadrant memorized, good to go, right?
Or Miss McGee, why
Yes.
can't you put, why didn't you put the 3 pi over 4 times 6 get that in your side? Why do you not? Put it in finding the problem. Everybody numbers like 2 and 3.
Well, it was 2 pi over 12 and 3 pi over 12. That was whenever I converted.
Oh, that's not.
Yeah. What's the sine of pi over 4? Quick, quick, quick. That's an easy one. What's the cosine of pi over 6?
I don't have that memorized.
Cosine pi over 6, that was the square root of 3. That would be square root of 6. Cosine is the x value. No doubt.
So this is square root of 6 over 4, square root of 2 over 4, and you have an answer that is the square root of 6 plus the square root of 2 over 4.
Yes, it's here. It's the 3rd page, top right.
Oh, yes. So this, and this is how they got this. If you factor out a square root of 2, for whatever reason you may want to do that, this would be the square root of 3. 2 square root of 2 divided by square root of 2 is 1. That's the same thing.
Why would the scroll up on the thing a little bit?
Well, but you have to find your answer on the circuit.
I can get the sign part up top with the pi over. Like once you have pi over 4 and pi over 6, how'd you get the sign?
Look on your unit circle. The sign, you go to pi over 6, sign is the y coordinate there. Divide.
Yeah, so you get, why you plus 1?
Because I took it out of both of them. It's kind of like if you have 10 plus 5 and you want to factor a 5 out of both of those, you take it out and put it on the outside and then you put what's left. So 2 plus 1.
Right here, when you have these two, like once you get those two things from the pi over whatever, how do you add that sign to the front? Like, how do you know to do that? Like right here. How'd you do it with that sign right there?
I don't understand.
Can I show you?
Yep.
So like, yeah, just right here. How'd you know to put that sign right here?
Well, that was the original problem.
Oh, duh. All right.
All right. Number 12. I'm going to let you do number 12, but I'm going to tell you what the answer should lead to. Because I'm not going to force you to use certain reference angles. I have it written down on my desk, but it's not worth going into 30 minutes on which angle she used. I used 45 and 210 on there. Again, you're just picking two angles that are on there. When you go through, you should end up, and go back and do it, but you should end up with 3 plus root 3 over 3 minus root 3. It ends up, which actually ends up being the same thing, believe it or not, as the square root of 6 plus the square root of 2 over the square root of 6 minus the square root of 2. And this is where I want to take a minute to explain this problem. As long as they add up to that, yes. Use any two on your, And you can add or subtract. This is addition or subtraction. All right, let's look at 13 because it's my fave. I love 13 and 14. Go back and do 12. Go back and do 12 so we got time to get through 13 together. 13 is this one. I'm sorry. It's hard to answer questions on circuits because unless we go through every one of them. Tangent of 45, any 45 angle is 1. Katie, you good? Okay. All right, 13. Tangent is sine over cosine, yes. Square root, it's on the second page. The second page, middle left.
Wait, I think the answer is 2.
I can't figure it out.
What?
I can't figure out the tangents to 10.
No.
I can't figure out
The tan of 210? Where's 210 on your sheet?
my unit circle.
Yeah. Where is it? It's right here, right? 7 pi over 6? No. I know, but where is 210 degrees on your unit circle?
Oh, 7.5.
Okay. So what is sine divided by cosine there? Y'all, please make sure you add on your quiz tomorrow. You're going to have tan values you're going to have to put on your unit circle. Oh yeah, in fact, I'll probably take that and add another blank or make it a little prettier where I can have the blank on there. But it'll be obvious you have to do it. I just want y'all to remember to study it. What'd you say? So instead of dividing, multiply by reciprocal. No. It's sine over cosine. So it's negative 1/2 times negative 2 over root 3. Which is 1 over square root of 3. And then you have to rationalize. So square root of 3 over 3.
I think it's sine over cosine, so you have to
It is.
multiply the 3 over 2.
So it's sine is negative 1/2. At 210?
Cosine's x value.
No, you labeled your points wrong.
You labeled them wrong.
It's square root of 3 over 2 1/2 is that. Let me ask you this. Which number is bigger, square root of 3 over 2 or 1/2? Okay. So the longer side, does it go out further or down further? It goes out further than it goes down, right? So your x should be bigger. All right, look at 13 with me quickly because I want to make sure I have time to get through this because you have several that you have to approach this way. So it says if sine x is 1/3 and x is between 0 and pi over 2, what does that tell me if x is between 0 and pi over 2? I'm in the first quadrant. That's my easy reference angles. That should not be a problem for me, right? It says then sine pi over 4 plus x equals what? So what I'm going to do is use that identity, that additive identity for sine, right? So if you look, I'm in sum and difference identities, the very first one for sine. It says, what does this equal? But you should get a specific value here. And I'm going to show you how. All right, so we do sine pi over 4 cosine x plus cosine pi over 4 sine x. Yes, everybody okay there? These are easy. What are those? Square root of 2 over 2. Both of them are the same. Square root of 2 over 2 cosine x plus square root of 2 over 2 sine x. So if you go back, oh, and look at what I was given in the beginning. So let's plug that in. What you flipping? All right, this is where I would expect you to get stuck. So you have square root of 2 over 2 cosine x plus square root of 2 over 6. And you go, oh, I can't do anything else, right? But can you? Any ideas what I can do? Meg, I'm so impressed. Did you think of that on your own? Okay, so she went back to geometry. If you have sine x, let's think about a triangle. Okay, if this is x is my angle or my theta or whatever. Sine is opposite over hypotenuse, right? Opposite over hypotenuse. You have a right triangle with two sides. Can you find the third? Pythagorean theorem. A squared plus b squared equals c squared, right? So 1 squared plus b squared equals 3 squared. What is b squared? 8, right? So b is the square root of 8 or 2 root 2. Remember when we simplified radicals?
Why are you connecting that to like?
Because I need the cosine of x. Cosine is adjacent over hypotenuse. This is adjacent. So by forming this triangle, I found the cosine value. Okay, so it told me that sine of x was 1 over 3. So that means from the angle in the triangle, it's opposite over hypotenuse. So the opposite is 1 and the hypotenuse is 3. And then I use Pythagorean theorem to find my last side. Isn't that cool? So what's the cosine of x? 2 root 2 over 3. And to that, I'm adding square root of 2 over 6. Okay, so, well, on the top, I can cancel these 2's out, right? And the square root of 2 times the square root of 2 is 2. So I have 2 over 3 plus square root of 2 over 6. 4 over 6 square root of 2 over 6, which is 4 plus root 2 over. That answer is one of your choices.